Hi, this is Dr. Nick with the ECG Academy with the second chapter in section 5, talking about the limb leads. Here we are going back to the idea that the heart in the chest is creating this electrical signal that's traveling in a direction, usually down into the left of the patient. Okay, that's the idea of a vector. A vector is an electrical signal that has a direction. And so, how do we record these vectors and how do these ECG leads make sense? Well, we talked about Einthoven's triangle, and Einthoven decided that he was going to use the right arm, the left arm, and the left leg to create this electrocardiographic view of the heart. Remember that lead 1 is moving, anything that moves from the right arm to the left arm will be in lead 1 will appear to be upright in the cardiogram. Lead 2 are signals traveling from the right arm to the left leg because that's where the wires are connected, and those are the electrical signals that lead 2 is picking up. And then lead 3 would go from left arm to left leg. Those are the wires that are used to derive lead 3, and any signals going in this direction will be upright in the ECG lead. Of course, conversely, anything that's going in the opposite direction will show up as a negative deflection on the EKG. Okay, I just want to make that clear. So that gives us an idea. If we look at any one particular lead, we can tell what direction the signal is going in. Okay, well, a triangle is a little difficult to understand. So, because we have the augmented leads in there as well, AVR, AVL, and AVF. So, I like the idea of a circle. The circle representing the frontal leads, which are the leads that we see in the front of the patient when we're viewing the front of him. Okay, and this circle is divided into 360 degrees. By convention, we usually divide this into 4 quadrants. And we consider that this angle to be 0 degrees, and the degrees go upwards from here, and negative degrees are this way. This will make a lot more sense when we talk about axis. But let's review what the ECG leads that we have in Einthoven's triangle are. We have lead 1, which is going from right arm to left arm, and that's going straight across, so we can draw it in this circle looking like this. So lead 1 is drawn straight across and is pointing to 0 degrees, and will record any activity that's going in a horizontal direction. Now lead 2, how do we remember that lead 2 is going from right arm to left leg? Well, I always remind people that in English, at least, we read from left to right and from top to bottom. And so when you're ready to draw the second ECG lead in, you want to draw it from left to right and top to bottom. But it has to divide the circle into 6 parts because there's 3 leads, and they'll all bisect the circle. So where do you draw it in this quadrant here? You draw it 60 degrees above the horizontal, so that divides it like 60 degrees. Remember, there's 60 degrees in every corner of an equilateral triangle for you guys who actually passed geometry. And so lead 2 is drawn just like this, which is 60 degrees up from the horizontal, going from the right arm to the left leg. But it's beginning to divide this circle into 6 equal parts. Now lead 3, which is from left arm to left leg, we would naturally draw just like this and label it lead 3. And thus we've divided the circle into 6 equal parts, and we've defined angles that correspond to these 3 basic ECG leads. Now what about the augmented limb leads? Well, the augmented leads kind of split these 60-degree angles in half because AVL, which is sort of the left arm compared with the sum of the right arm and left leg, is kind of pointing towards the arm itself. And so what you get is this kind of an angle, with the head of the vector heading this way. So this is AVL, and likewise AVR is drawn 30 degrees above the horizontal in this direction, pointing towards the right arm. So this is AVR, and then of course AVF would have to go right down the middle. So that's AVF. And so we've now split this circle into 12 equal parts, each one corresponding with one of the 6 limb leads that we see on a standard ECG. Remember what these look like. We have 1, 2, 3, AVR, AVL, and AVF. Those are the limb leads on the first part of a 12-lead ECG. All right, let me get rid of that for a second and go back to this drawing. Okay, now the idea behind the leads being important has to do with the direction of the electrical signal. So let's say that in this normal person, you have a vector that's traveling down and to the left. So now if you happen to be monitoring, let's say lead 2, which would be going from the right arm to the left leg, the signal is traveling along lead 2 in that direction. And so when you look at the EKG in lead 2, you're going to see a large positive deflection of both the P wave and the QRS complex. Well, let's say now you go over to that monitor and you switch the selector to AVL. Now, AVL is going to be in this direction. Now, we've already decided that the vector is traveling in this direction. So AVL is almost perpendicular to the direction that the vector is traveling in. And so when you look at AVL on your monitor, you may only see a little tiny deflection. And it wouldn't exactly be a good lead to monitor because the QRS complexes are so small. The monitor may actually double count the P and the QRS, or it might not pick up anything at all, and you'll get heart rates of 0, and that makes the patient's family really upset when they look up at the monitor and see heart rates of 0. Because the monitor is not picking up the QRS complex. So switching to a lead that will pick up a larger signal makes a lot of sense in those cases. Now, the proof of what I was saying is in this ECG, because here you have an example of where the signal is very large in lead 2, but it's much, much smaller in AVL. And so it's a similar situation to what I just described with the axis that's going in the direction of lead 2. Because of that, it's going in the perpendicular direction to AVL, and the signal that you record is much, much smaller. Doesn't it make sense now? Okay, so the basic concept of a lead is that you can, in fact, get a sense of what direction things are traveling. By switching leads, you can get a better view, an electrical view of the heart, because the signal is traveling along that lead rather than perpendicular to it. And in the intermediate course, we'll start to talk about axis, which is basically the exact angle that the QRS happens to be at, where you actually have a normal range between minus 30 and plus 120, where that vector or the axis of the electrical signal is normal, and anything above or to the right of that is going to be abnormal and define axis deviation and allow you to diagnose crazy things like left anterior hemiblock and other kinds of advanced electrocardiographic diagnoses. So with this discussion of the limb leads, we'll get ready for Chapter 3, which is going to be a review of the precordial or V leads and the kind of things we look at when we examine those. And then in the next section, we'll start to analyze the QRS complex itself using real tracings and start to talk about real electrocardiographic diagnoses. This is Dr. Nick with the ECG Academy. Thanks for watching.